If you are studying energy, power, and climate for the IB, you probably need to know a little bit about waves and how waves can be used to generate power as well. And we're going to deal with how you can calculate the energy from a wave, which is a little obscure but not that difficult. And while you do need to know stuff about the OWC, or the oscillating water column, the OWC, just look that up. You can read it. It's not the most complex thing. I'll help you concentrate on the problem-solving mathematical part of it. You've got some waves coming through, and they're going to hit your OWC, or your oscillating water column here. Here you've got your turbine, and this water level is going to go up and down, pushing air out and turning the turbine to turn the generators, and that's how most all power production works, except solar. Now, what you've got is you got the wave speed of 4.8. It's 10 meters from top to bottom. That's not the amplitude. That's from crest to trough. And the question might read this. Now, give this a pause, look your data booklet, see if you can solve it. Now, in your data booklet, hopefully you found the equation that says P is equal to 1/2 a squared rho g v. Now, hopefully you are aware that this a is no longer area, like with windmill. It is standing for amplitude of the wave. And in this case, the amplitude is not 10. That's a clever trick. If you fell for that sucker, it's actually half that, 5 meters. The density is the density of water, which is 1,000 kilograms per cubic meter. You know g, the velocity is given up here. So you plug in some stuff. 5 meters squared, 1,000 kilograms per cubic meter. Your 10 meters per second squared, and your velocity of 4.8. Now the units work out a little bit funny, and you'll notice, well, you're not going to do all the units, but take my word for it. The clever thing about this, maybe the frustrating thing, this isn't a power equation. It's actually a power per width of the wave equation. The IB doesn't tell you that in the data booklet. I think that's a little dishonest, because the answer you get here is going to be 600,000, not just watts, but watts per meter, because it's actually a power per width. And what you have to do is you take this power per width, or this 600,000 watts per meter, and to answer this, you multiply it by the 2-meter wide wave. And then you get the very simple answer of 1.2 megawatts is your correct answer here.